Good evening, everyone. Welcome to CML Infotech. My name is Muhammad Ali, Senior Technical Instructor, CML Infotech. The last day, we were discussed about certification requirement, local area network, wide area network. And I had put one question regards with ISP services. We'll come across on the last session today. So, as we remember, we had discussed about until the symbols or until wide area network. I'll give you a summary. If you have a network which can connect a cables to implement as a network with the help of a cable called network, which is a wired network, irrespective of the length or the location or the building or the campus, etc. Wide area network, which means if you have a network which are in different location and you need to make them connect. So if you cannot pull the cable, or if the network is beyond your limit by pulling the cable, you should approach the ISP or service provider who can provide you the technology in order to connect to your, as an example, to your main office, to your branch office, which we say wide area network. This is a general idea, and we will dive deep into the specific topic on upcoming classes, including the hands-on experience. So the next topic today we will discuss about network topology. In the network topology, we have bus, ring, star, extended star, mesh, and hybrid. So within this, the bus and ring we are not going to use much because these are outdated technology. We are more drive into star topology. However, we will come across with certain points. The bus topology, which means the straight coaxial cable can use to connect to your systems. ഒരു സിംഗിൾ കോആക്സിയൽ കേബിളിനകത്ത് കമ്പ്യൂട്ടേഴ്സിനെ കണക്ട് ചെയ്യും. ഇങ്ങനെ കണക്ട് ചെയ്ത് ടി കണക്ടറൊക്കെ വെച്ച് കണക്ട് ചെയ്താൽ ഏതെങ്കിലും ഒരു സിസ്റ്റം ഡൗൺ ആയി കഴിഞ്ഞാൽ കുഴപ്പമില്ല. അതേസമയം ഒരു കേബിൾ ഡൗൺ ആയി കഴിഞ്ഞാൽ, മെയിൻ ബാക്ക് ബോൺ ലിങ്ക് ഡൗൺ ആയാൽ അവിടെ നിന്ന് അങ്ങോട്ടുള്ള സർവീസുകൾ ഡിസ്കണക്ട് ആവും. ഇതേപോലെയാണ് റിംഗ് ടോപ്പോളജി. റിംഗ് ടോപ്പോളജി വിച്ച് മീൻസ് അതിൻ്റെ കോൺസെപ്റ്റ് ആണ് റിംഗ്. The concept of the technology called ring, but still the physical connectivity, you will have a central hardware called MAU or MSU, multi-access unit or multi-station access unit, which is a central hardware like a switch. You will be connecting all your system into that device, and the token will run behind that to get to know who needs the data or to whom should we communicate. We are not going to deal more about ring, by the way. We will jump into star topology. We have more concept to understand from this star topology. By looking into this, you can see all the nodes or the end devices mentioned in the circle are connected to a central device called the switch. So let us say you have a switch from many vendors, including Cisco, Aruba, Juniper, Extreme, Avaya, and there are many more. So you have a switch here. Obviously, the switch will have a port. So you will have a port number. We'll come across what is port and what look like, and all these details we can come across in later. So let's say I'm going to make some ports, some space. And I have some computers here in the network. I connected few systems via Ethernet cable, or also called as a UTP, or we can call as Ethernet cable, copper cable, UTP cable. It can be anything. So your end devices, as an example, computer connected to your central device. Example, we call as switch. We can call as a PC. So when you have a just a two computer, maybe a laptop, maybe a normal computer, maybe a server, anything. If you have just two devices and you would like to communicate between them, then you can put a cable between them straightforward like this. Keep in mind, when you think about connecting two systems, then you have to have network interface card on both the system, NIC. So you will be taking a copper UTP cable and connecting from one computer to another computer through NIC, or using one NIC to another NIC. Then let's say you have more than two computers. So instead of connecting between two computers directly, you will be connecting to your switch from the respective edge device like a PC. So the NIC of the PC will be having connection to to a switch. ഒരു കമ്പ്യൂട്ടറിൽ നിന്ന് അടുത്ത കമ്പ്യൂട്ടറിലേക്ക് ഡയറക്റ്റ് ഒരു കേബിൾ കണക്ട് ചെയ്താൽ രണ്ട് സിസ്റ്റം തമ്മിൽ കമ്മ്യൂണിക്കേറ്റ് ചെയ്യാം. രണ്ടിൽ കൂടുതൽ കമ്പ്യൂട്ടേഴ്സ് ഉണ്ടെങ്കിൽ ഒരു സ്വിച്ചിലേക്ക് എല്ലാ കമ്പ്യൂട്ടേഴ്സും കണക്ട് ചെയ്യണം. Which means ரெண்டு கம்ப்யூட்டர் மட்டும்தான் இருந்தால் அதுக்கு டைரெக்டாக ஒரு கேபிள் போடலாம். ஆர் டூ மோர் கம்ப்யூட்டர் இருக்குன்னு வச்சுக்கோ. ஸோ ஒரு சுவிட்சில் டைரெக்டாக வந்து சுவிட்சில் எவ்வளோ போர்ட் இருக்கோ அந்த போர்ட்டில் எல்லாம் வந்து கேபிள் கனெக்ட் பண்ணி வச்சுருந்தா, this technology we considered as, or this design we generally referred as star topology. So do not think that it look like a star. No. Maybe your switch will be placed somewhere on the corner of the room, and your system is across the room, across the floor, across the building, anywhere. So you will be pulling the cable from your computer towards to your switch. There are some technical terms which we called as IDF, MDF, data center. This will come to know later, inshallah. So this is we call as star topology. This switch can be from any vendor, maybe Cisco, Juniper, Aruba, or any other vendors. So if you, and the system can be any other devices, like example, let's say IP phone, camera, access control system, BMS, building management system, or access point for the Wi-Fi solution, or it can be any other devices. So those edge devices, if you connect it to your system directly, from your system to the switch directly, we called as star topology. Hope you understood this concept, and we will come across with this technology with more hands-on. And we can see another design called extended star topology. The extended star topology is one of the common design which is going through the current network. Like, just to imagine, you have a 5 floor, and every floor you have a computers, either computer, either IP phone, either camera, or any edge devices you have on every floor. So instead of pulling a cable from every edge device to focusing into one floor, like ground floor, first floor, second floor, third floor, and fourth floor. So you're keeping your switch in the ground floor, and Pulling the cable from every different floor towards to the ground floor switch, it's not a good design. So the best practice and the recommended solution is that put the switch on every floor, depends upon the number of edge devices located on each floor. So in a simple way, ground floor 20 computer ഉണ്ട് അപ്പം 24 പോർട്ടിൻ്റെ ഒരു സ്വിച്ച്, ഫസ്റ്റ് ഫ്ലോറിൽ ഒരു 20 കമ്പ്യൂട്ടർ ഉണ്ട്, 24 പോർട്ടിൻ്റെ ഒരു സ്വിച്ച്. അങ്ങനെ ഓരോ ഫ്ലോറിലും എത്ര കമ്പ്യൂട്ടേഴ്സ് ഉണ്ടോ ആ കമ്പ്യൂട്ടേഴ്സിനനുസരിച്ചിട്ട് അത്രയും പോർട്ടുകൾ വരുന്ന സ്വിച്ച്. അപ്പോൾ പോർട്ട് ഒരു കൺഫ്യൂഷനാണ്, എക്സ്പ്ലെയിൻ ചെയ്തു തരാം. എല്ലാ ഫ്ലോറിലെ ഡിവൈസുകളും കമ്പ്യൂട്ടേഴ്സ്, ക്യാമറ, ആക്സസ് പോയിന്റ് എല്ലാം ഒരു ഫ്ലോറിലുള്ള എല്ലാ ഡിവൈസുകളും അതാത് ഫ്ലോറിലെ സ്വിച്ചിലേക്ക് കണക്ട് ചെയ്യും. ശേഷം എല്ലാ ഫ്ലോറിലെ സ്വിച്ചുകൾ തമ്മിൽ ഇന്റർ കണക്ട് ചെയ്യും. ഇതിനെയാണ് നമ്മൾ എക്സ്റ്റൻഡഡ് സ്റ്റാർ ടോപ്പോളജി എന്ന് പറയുക. അങ്ങനെ എല്ലാ ഫ്ലോറിലും കമ്പ്യൂട്ടേഴ്സും ഉണ്ട്, എല്ലാ ഫ്ലോറിലും സ്വിച്ചും ഉണ്ടെങ്കിൽ ഒരു മെയിൻ സ്വിച്ച് ഇരിക്കുന്ന ഫ്ലോർ, അതായത് നമുക്ക് ഗ്രൗണ്ട് ഫ്ലോർ കൺസിഡർ ചെയ്യാം. ഗ്രൗണ്ട് ഫ്ലോർ മെയിൻ സ്വിച്ച് ഉണ്ടെന്ന് വിചാരിക്കാം. ആ മെയിൻ സ്വിച്ച് ഇരിക്കുന്ന ഗ്രൗണ്ട് ഫ്ലോറിനെ നമ്മൾ MDF എന്നും മറ്റു സ്വിച്ചസ് ഇരിക്കുന്ന സാധാ സ്വിച്ചസ് ഇരിക്കുന്ന സിസ്റ്റം കണക്ട് ചെയ്ത സ്വിച്ചസ് ഇരിക്കുന്ന സ്ഥലത്തിന് നമ്മൾ IDF എന്നും പറയും. സോ in a simple way, what you need to understand from the extended star topology, just a simple idea. You have multiple switch and all the switches are interconnected with each other. In that we called as extended star topology. Doesn't matter how many switch that you have, how many link that you have in between switches, that is a later part. But if it is a single switch design, one switch with a many computer, we generally called as a star topology. If you have a many switch and many switches are interconnected and all those switches have edge devices connected on it and they are trying to communicate each other, we call as an extended star topology. Again, we will come across with this technology with more practice, more hands-on. Then the mesh topology. The mesh topology generally considered in the ISP, Internet Service Provider, or on the core, on the telecom side. Mesh topology, which means you will have end-to-end connectivity. Let's say you are sitting on the router A or as a device and you need to reach to router E. So if you fail one link towards to your destination, you will have multiple of other link to reach on a specific destination. So this is we call end-to-end connectivity, mesh topology. Again, we will have some concept and explanation and the practical design for the mesh topology during our routing class. So what you need to understand, when you send something, or in a simple way you think, we as an end customer, we are sending a query to a specific server over the internet, like for the Google, Yahoo, or any other services that we put into our system. This query, whatever we put it in the Google Chrome or wherever, those queries will goes to the ISP, and ISP will reroute those into a specific server. And during that time, we will never face any failure. Maybe there could be a failure happening in the ISP side, maybe, even though we are not able to identify even a single point of failure. So we can reach our target as soon as the best by having multiple links in between ISPs. Also, keep in mind, there are some SLA, service level agreement, between an ISP. If one link goes down from one ISP, there could be another link which given by another ISP towards to your destination by mentioning some sort of SLA concept. We will explain in the later classes. So mesh topology is nothing but you will have more than one link towards to your destination. And again, hybrid, which again, if you connect with the multiple LAN technologies like a star, bus, ring, then we called it as hybrid topology. Then network models. I believe most of the points that might you clear or you know about it, even though we're just giving a brush up to understand towards to our CCNA class. Network models. We have a peer-to-peer and server-based. There is a two name on it, peer-to-peer and server-based. In a general way, if you think as a few people connected each other through computers, like I have a Windows 10, you have a Windows, let's say 7, the other people have a Windows 12, or some other people have Windows 2016, different OS that we have. Even some people have a Linux, some people have some other Windows, other operating system, and few have different flavor from Windows. We all are connected each other. Then within us, no one have any specific privilege. Anybody can send data to anyone within us. And if one of the system goes down, there is no issues to others. If you think in such a scenario, we call as a peer-to-peer network. ഒരാൾക്കും ഒരു സ്പെസിഫിക് പ്രിവിലേജ് ഇല്ല. എല്ലാവരുടെ സിസ്റ്റവും കോമൺ ആയിട്ട് വർക്ക് ചെയ്യുന്നു. ആർക്കും ആരെയും കൺട്രോൾ ചെയ്യാൻ പറ്റില്ല. No one can control each other. All are individually controlled. Then we call as a server, then we call as a peer-to-peer network. No centralized management. Anybody can leave from the network, or anybody can join the network at any time. They all are working as independently. So then we call as a peer-to-peer network. And also we can add any OS into a network, which we call as a peer-to-peer. The server based, which is quite common and most of us are more relied with on this server based network. Server based in the sense there are systems or one system acting as a server and the rest of the system acting as a client. In this scenario, we call as a server-based network. There are a few more topics you need to clearly understand in order to get an idea about server-based network. Okay, so there are some theory as well. One system can manage all the remaining as a centralized PC. So what does that mean by manage? Let's say a system who are centralized to manage can manage other systems. How do they manage? The manage, which means the server system can provide username and password or credential to log into the client. Let's say I have a computer acting as a server and you have a PC acting as a client. In shortly, I am a server, you are my client systems. So I'm going to create a username in my computer individually for you guys. And I'm giving you a username called, as an example, I'm giving a username called A. And I'm giving to that username A to the system A or the people who are handling system A. So that person can only log in to that system. They cannot log into another system. That is a one set of privilege. Second, I can set the time frame. He can log in morning by, let's say, 9 o'clock, and he can log out it by 5 o'clock, which means if he tried to log in after 5 p.m., they cannot. So this is another privilege. Then I'm going to give a set of rules in his system. He can log in only a certain file, certain folder. He cannot log off. Oh, sorry, he cannot delete the files, or he cannot shut down the computer. There are many can set up. If a single computer can do all these services to manage their resources, to manage their other computers, then we called that specific system we called as a server. Okay, that server can have many systems as a client. This we call as a server network. So shortly, what you need to understand, a central system who can manage all the remaining computers, then we call that system as a server, and the remaining system we call as client. I'll make it a little more clear on about this. So let's say, when you think about to make a server and the client platform, of course, you will have a switch because you have more than two computers. So I have a switch and I have a server. So let's say when I put this is my server, then I have one, two, three systems. Example, this PC is called PC1, PC2, and PC3. Okay. The first task for me or for us to make a connectivity. Let's say I'm creating a connection from my system to my switch. And another criteria that I need to assign an IP address, which will be learned later, um, more about the IP concept. When you connect a system, yes, there are new concept called one PC, one device can manage multiple services, multiple appliances, multiple applications called as a VMware. So do not think in such a higher level. Think about as a base. For us, just need to understand what is server and what is client. That's it. Okay. So you have a four computers. When you connect a net system into a switch and when you make them as a network, no system will have a default privilege as a server. All are treated as equal. In order to make us one computer as a server and the remaining as a client, there are some requirements from the software level and from the hardware level. From the hardware level, as we set, or as an example, as a hardware level, we need, let's say, minimum number of CPU, minimum memory, minimum level of hard disk to store the data, a kind of configuration. Generally, we go for a server-based platform like HP or Dell, etc. And the system can be anything. If you move all this point to away, just to make a configuration perspective, how can we make one system as a server and the rest of them as a client? The first criteria, we need to have a physical connectivity. And the second thing, you need an operating system. That is one of the mandatory stuff. So there are two different OS, server-based OS and client-based OS. So let's say, in order to make us a server-based OS, we can see some of the server platforms, server series. Like the client OS are different than the server OS. The server OS can act as a server as well as a client, but the client OS can always act as client only. So you need one of the server OS. Let's say we're going to think about, we're going to install 2012 server OS Windows, and the client we can install, let's say 2010 Windows. This is up to us what OS that we need to choose. So here my server OS is Windows 2012, or let's say 16 server OS. And this is, let's say, Win 10, Windows 10, and Windows 10. So the first thing that we need to install Windows. We installed all. The moment you installed Windows 2016 Server OS, it will never become auto server. We have to make it by manually. Okay, so you need, in order a server to become a server in the sense a system who provide services. This is called a server. A PC, the client in the sense the device who accept the service from the server in a short way. So our requirement here is I need a one system who will be managing, controlling another systems. So in order to deliver the services from the server or like a centralized management, we called as domain. We called as domain, or we called as domain controller. So the system must be domain controller. In order to make a domain controller, one of the criteria I need DNS. DNS is also one of the big topic. I need a DNS. In a short way, DNS is used to convert the name to IP and IP to name, vice versa. I need a DNS, so I need to configure DNS. When you configure the DNS, it looks like example like SRV is my server name, like a PC1, PC2, PC3. When I did the DNS configuration, it will become something like domain name. Example, CML Infotech.com. So the CML Infotech.com is the DNS name. This is the domain name. When it comes with a complete name, example srv.cmlinfotech.com, then this name we called as FQDN, fully qualified domain name. So the first task before you make a domain controller, you have to configure DNS. The SRV is the default host name or SRV is the host name when you configure the server. CMLinfotech.com is an example name when you configure DNS. Then you will configure domain controller configuration on the Windows 2016 server OS. Later, once the domain is up and running, you will be adding your client system into a part of your server domain. So when you install your Windows 10 individually, you will have individual login like administrator and the username like password. When you add the PC1 into your domain controller, the full name of your Windows 10 PC1 would be, or it will become like, PC1, whatever the name that, example, I put the capsule one, PC1 dot, then the domain name, which we'll call as again cmlinfotech.com. So your company name, your system name dot your company name, your complete name. So this name we generally referred as fully qualified domain name. So whenever your computer is adding into your domain, in order to avail your company services like a shared folder or kind of any other internal services like Outlook, anything which you can, your system must be a member of your company domain or your domain. So this pc1.cmlinfotech.com is your company name. Then the person who are going to use the system, like a PC1, going to use a name called, as an example, user1 is the login which we will be creating in the Windows 2016 server OS. Then the full name of this user will become user1 at cmlinfotech.com. So in a short way, user1 as a new employee in our office. So IT department will assign a laptop to him by formatting all the existing data, and he's giving a fresh system to him. When a system is given into him, the IT domain will be adding that computer into the domain name, and the IT admin, IT person will be creating a username as a user one and assigned to him. So he can join or he can log in his system by using user one as a username. So a Windows 2016 server can put a restriction that user one can log in only in his system, not to others, and also putting some other instructions, some restrictions, etc. So the user one is the user who is logging into the PC one. The same way, the person who is controlling the domain controller we call as enterprise administrator. Enterprise admin. The administrator who have a full privilege to log in to maintain the domain controller called enterprise admin. Same as other user, but he has full privilege. Okay, so coming back to the point, what we discussed, server-based OS. When you say server-based OS, you should have a minimum one server and the many clients. It can be 2, 3, 1, etc. And the server can manage all your clients. In order to become a server, the centralized management server is a services from the server OSs. That services we call as a domain controller. So the person who are managing that domain controller called enterprise admin, and he can create different users with the different privileges to a specific system. Okay, this is all about just another. This is all about just an awareness about server-based network. So this is all about Windows Server configuration and the idea behind the Windows server-based platform.